and tell the domain, range, and behavior of the graph. Yesterday, we had graphed this one, right? And we did the domain and range, but we didn't do the behavior. Okay, let's finish that up. Tell me some, let me graph it really quick. What were your x values? Okay, and when -3 was the x value, what was the y value? Okay, then, okay, let me show you a little pattern. Every time you increase the y values, how are they increasing? They are doubling, right? I mean, it's not as easy to see right there, but you can tell that from 0.25 to 0.5, that's doubling. 0.5 to 1 is doubling. 1 to 2 is doubling. 2 to 4 is doubling. 4 to 8. Look, that's because your growth factor is a 2 for doubling. Okay? So I'm going to quickly graph these. I know you already got them, so I'll make it quick. Okay, so that's what our graph looked like. And the asymptote was at 0. Because on the left side, where all the negative numbers were, we noticed that they were getting smaller and smaller, closer and closer to 0. Now, yesterday we quickly did the domain, but I want to recap that because it was very rushed. When you hear the word domain, you think about what? X values, so left to right. If you're on this exponential curve and you go left, how far can you go left? Forever, and forever left is negative infinity. If you're on this curve and you want to go to the right, how far can you go to the right? Forever to the right, which is positive infinity. Now, we are used to writing this with just a comma between them. But on this test, they write it with inequalities. They'll write x in the middle for domain, and then they'll say that x represents the curve, and the curve is less than infinity, but it's greater than negative infinity. That's how they write it on this test. Okay? Now let's talk about the range. Range is about y values. So if domain is left to right, range is down to up. How far down will that curve go? Correct. There's an asymptote that prevents it from going below 0. So the lowest it goes is 0. How high will it go? Infinity. But then it's range. So you put a y in the middle, and then it's less than infinity, but greater than 0. Okay, now for in behavior. It'll be written out like this. It'll say left, and it'll say right, and then it'll have y approaches, y approaches. If you go to the left side of that curve, okay, which is this way, what are all the y values approaching? They're getting closer and closer to what y value? 0. Think about it. Isn't the left side of my curve approaching the asymptote at 0? If you go to the right side of the curve, the y values are all getting higher, and we'll do that forever, so infinity. Whenever you're writing your in behavior, you're basically using the same values from the range, 0 and infinity. You just have to know which one to put where. Okay. Like, see how the left side of the curve is approaching the asymptote? Like, look, okay. As I'm coming to the left, the points are getting lower and lower, right? On the y-axis. Aren't their y values getting closer and closer to 0? So that's why it says that as you go left, the y values are getting closer to 0. Think about it from a table standpoint. If you look at the table, and we go to the left side of the table, which is this way, aren't these numbers getting closer and closer to 0? If we go to the right side, the numbers are getting bigger and bigger, and we'll do so forever, so infinity. Okay, let's look at number 2. Let's do a quick recap from yesterday. We are learning about exponential equations. Exponential equations are written y equals a times b to the x power. A is your starting value, b is your growth or decay factor. Now, to decide whether it's growth or decay, if your b value is greater than 1, it's growth. And that means your graph would be going up from left to right. It would be increasing from left to right. If your b value is less than 1, but greater than 0, because it will never be negative, it's a decay. And that means it would be going down from left to right. So for this new problem, number 2, what is the a value? 1. Isn't there an understood 1 in the a place? There's nothing there, so it's an understood 1. What's the b value? 1/2, or 0.5 if you want to write it as a decimal. So that means this time we're dealing with a decay, because 1/2 is a number between 0 and 1. So we already know, like if this were a multiple choice test, the decay would be going down. Okay, you would pick a graph that was decayed. Now, doesn't A also tell us where the graph starts? So it starts at 1, because your A value is 1, just like this one did, because its A value was 1. But to get the rest of the points, we need a table of values. So X and Y, and then I'll just fill in the same numbers. What do we do with those numbers to find the Y values? Plug them in. So go ahead and do that. You plug like -3 into the X. So you would type in parenthesis 1 divided by 2, parenthesis to the -3 power. When you plug in -3, you get 8. When you plug in -2, you get 4. When you plug in -1, you get 2. Let's look at a pattern here. What's going on? What's the pattern? It's going down by 4. They're halving, right? And isn't that because your decay factor is 1/2? So what's half of 2? What's half of 1? What's half of 0.5? And what's half of 0.25? Okay, do you see the pattern because it's decaying by half? Okay, so now let's graph these. Left 3 up 8 would be negative, or left 3 up 8. -2, 4 would be left 2 up 4. -1, 2 would be left 1 up 2. 0, 1 would just be up 1, which I already knew there was going to be a point there because the a value, the starting value, was 1. 1.5 would be right 1 up a half a block. 2.25 would be right 2 up a quarter of a block. And 3.125 will be right 3 up an eighth of a block, which you're barely going to be able to distinguish between the quarter because of the space we have. So we can see that this graph is definitely a decay because from left to right it's decreasing and it's approaching the asymptote on the right side. And where is the asymptote? What are all the y values approaching as you go to the right? 0, like 0.5, 0.25, 0.125. They're getting closer and closer to 0. No. We'll see some today that don't approach 0. Okay, now, what is the equation of this asymptote line? Isn't the asymptote line a line that cuts through the y-axis at 0? So that's the equation of this asymptote. Same for this one. I think we read that yesterday. Y = 0 is the asymptote equation. Okay, domain. When you think of, or when you heard the word domain, you think of X. So left to right. How far will that pink curve go left? Forever left, which is -infinity. How far will the pink curve go to the right? Positive infinity. Because even though there's an asymptote there, does that keep it from traveling right forever? No, it just keeps it from going down forever. So you'll start to notice that for all exponential functions, the domain is always negative to positive infinity. It's the range that changes according to where the asymptote is. So the range is y, and how low will the curve go? And how high will it go? And positive, because remember, y is down to up, so up would be positive. Okay, behavior. For in behavior, it'll say left and it'll say right. And then they'll want to know what the y's are approaching. So, if you go to the left side of this pink curve, what are the y values doing? Going up forever. If you go to the right side of the pink curve, the y values are all getting closer to 0. Now let me show you something that's going to make your life so much easier. Okay, watch this. y equals, I'm just going to type in the equation. So parenthesis 1 divided by 2 parenthesis, there's my 1/2, to the x power, raised to the x power. Okay? Now, so we see that it's looking good, but to make sure we have the right points, can't we just go to our table? Look, negative 3a, negative 3a, negative 2, 4, negative 2, 4, negative 1, 2, 0, 1. Don't we have all of those points? And then, look, we didn't go past 3, but had we, see how, like, when you go to 4, 5, and you continue, that they're getting closer and closer to 0? Look what it turns into. Scientific notation, because it gets so small. There's so many zeros. Okay, it will approach 0 forever, but never actually reach it. It just continues to approach it forever. It doesn't. It's because it's hard for us to understand the concept of infinity. Okay, now go to the next page. So now you've basically learned that we don't have to create our own table. We can just graph it and use the table in the calculator. So first, before we even graph it, let's talk about some things that we know. What is the a value for number 3? 1. What's the b value? 2. But what else is there in this equation that we haven't seen before? This plus 1 on the end. In the previous 2 problems, there was nothing. So it was like a plus 0, which is why your asymptote was always at 0. Okay? But now we have plus 1, so let's see what that's going to do to the graph. Okay, so, look at the board a second. If a equals 1, that's our starting value. So wouldn't we expect our first point to be at 1? Okay, but let's graph it and see. Y equals 2 to the x power plus 1. Is our y-intercept at 1? Where's the y-intercept? 2. Why do you think it's at 2? The plus 1 on the end shifts everything up 1 unit. So yes, it started at 1 because a was 1, but this plus 1 shifted it up a unit, which also shifts your asymptote up a unit. So now my asymptote's at 1 because everything shifted up 1. Right. Okay, so now let's look at the table. Second table. Okay, there's some nice values that we can plot. Let's see. We'll start on the right side. 3, 9 would be right 3, up 9. Oops, wrong color. 2, 5 would be right 2, up 5. 1, 3 would be right 1, up 3. And then look, there's 0, 2. There's your y-intercept, because even though it technically was supposed to start at 1, the plus 1 on the end shifted it up to 2. And then negative 1, 1.5 will be left 1, up 1.5. Negative 2, up 1.25. Negative 3, up 1.125. So this time, as you continue going to the left, like negative 3, negative 4, negative 5, what are they all approaching? 1 this time. The asymptote's no longer at 0, it's at 1 because of this plus 1 shifting everything up. Okay, so your curve will be a growth. And why is it a growth? Because the b is greater than 1. Your b value is 2, which is why it's a growth. The reason the asymptote's at 1 is because of the plus 1. Yes? What? Oh, you'll have to go to another room. I don't have one. Right, so this time, if they're asking you to write the equation of the asymptote, it would be y equals 1, because it's a line that cuts through the y-axis at 1. Okay, does moving the asymptote up a unit affect the domain? No, it can still go left forever and right forever. The domain will always be that for all exponentials. It only affects the range. Okay, that invisible barrier only affects how far it can go down. How far can it go down? 1. How far can it go up? Infinity. Okay, for end behavior, left, right. If you go to the left side of this exponential curve, the y values are approaching 1. Okay, on the left side is where they're all approaching the asymptote. On the right side of the curve, they're all approaching infinity. Okay, take a second and try number 4 by yourself. What's the a value? 1. What's the b value? So this is a decay, okay, because your b value is less than 1 but greater than 0. Okay, well, what did this plus 1 do to this curve? So what do you think minus 1 is going to do? It's going to go down 1. So think about it. Listen, if your a value is 1, technically it would start at 1. But that minus 1 on the end will move everything down a unit, which will put your y-intercept at the origin, which will put your asymptote line at negative 1. So what's the equation of this asymptote? Y equals negative 1 is now where the asymptote has been moved, because it normally sits at 0. But if everything goes down 1 unit, the asymptote now sits at negative 1. Okay, now let's graph it to get some more points. It is, however, it starts at 1, but then this minus 1 tacked on the end moved it down a unit. Well, just use your table, okay? Alright, so y equals 1/2 to the x power minus 1. So 1/2 to the x power minus 1. So the graph will look like that, which is definitely a decay. See how it goes below the x-axis because the asymptote moved to negative 1? And now let's get some points from the table. Let's see, we can do negative 3, 7. So left 3, up 7. We could do negative 2, 3. So left 2, up 3. We could do negative 1, 1. Then 0, 0 we already have because we knew the rules that it started at 1 but then it got moved down 1, which placed it at the origin. And then 1, negative 1/2. 2, negative 0.75. 3, negative 0.875. So see how as you go to the right side, the numbers are getting closer and closer to negative 1, like negative 0.9, negative 0.9, like they get closer and closer to negative 1 because that's where the asymptote is. Yes? I went to y equals and I typed that in. You mean the table? Once you go to y equals and you type it in, you hit graph, and then you hit second graph to pull up the table. Okay, so now that we have our function graphed, what is the domain? Right? All of them will be that, every time. What's the range? Correct. Negative 1 to positive infinity. And then for behavior, as you go to the left side of the curve, the y values approach infinity. As you go to the right side of the curve, the y values approach negative 1, the asymptote. If it's a decay, it'll approach the asymptote on the right. Is that what you're trying to say? If it's a growth, the asymptote will be on the left side. Alright, so look up at the board for a second. If this plus 1 moved everything up 1 unit, and this minus 1 moved everything down 1 unit, what do you think's going to happen down here with x plus 1, but the 1's part of the exponent? Left or right? Which one? Left. Remember how the number on the inside with parabolas, it was always opposite of what you would think, what your common sense would tell you? So this is going to cause it to go left 1. So what's your a value? Your a value, 1. Your b value is 2, which means we're dealing with a growth. And think about it. If A is 1, that means the first point would be at 1. But it doesn't stay there because everything gets shifted left 1. So we're going to have a point right there, we know. But like I said, if you can't figure that out, the table will give you the points. So now let's go and graph it. Y equals 2 raised to the x plus 1 power. Make sure that plus 1 is a part of the exponent. Now graph it and go to your table. And there's you some nice points. I would go a little further to the left to get some points over here. So negative 3 up a quarter. Negative 2 up a half. Negative 1, 1, which we already plotted. 0, 2. 1, 4. And 2, 8. And look at the table. What are the y values doing every time? They're doubling, which makes sense because our growth factor is 2, doubling. Okay, as you go to the left side of the x-axis, the numbers are getting closer and closer to what? 0. Because even though it shifted left, that did not affect the asymptote. The only thing that will move the asymptote from y equals 0 is an up or down shift, a vertical shift. Left and right shifts will not move the asymptote. So for this one, the asymptote is still y equals 0. And then the curve is a growth because the b value is 2, greater than 1. So that's what it looks like. What is the domain for any exponential function? Correct. It's the range that will change according to where the asymptote is. What's the range for this one? To positive. Remember, because it's down to up, so up would always be positive. And then for behavior, if you go to the left side of the curve, it's approaching the asymptote, which is at 0. If you go to the right side of the curve, it's approaching infinity. Okay, so before we do number 6, let's write down everything we know. What's the a value? 1. What's the b value? 3. What will this x minus 2 do to the graph? Right 2. What will the plus 2 do to the graph? Up 2. And is it a growth or a decay? A growth, because your b value is 3. And if your b value is greater than 1, it's a growth. It's going to be going up from left to right. So look at the board a second. Your a value is 1, which means your first point started at 1. However, it doesn't stay there because it will move right 2 and up 2. So there's 1 point already that I know, just by knowing the rules that the first one started at 1, but it moved right 2 up 2, which landed it right here at over 2 up 3. Where is the asymptote this time? 2, because everything got shifted up 2 units. Okay, this number will tell you where the asymptote moves. Okay, now let's graph it and get some points. Y equals 3 raised to the x minus 2 plus 2. Okay, see how right there you can see it flatten out, and that's at 2 because the asymptote got moved up 2 units. And see how, like, when I go to the table, as I go left on the x-axis, they're getting closer and closer to 2. Okay, so let's plot a few of them. Negative 1, negative 2, negative 3, they're all so small and close to 2 that I'm not even going to put a lot of effort in. I'm basically just going to, put them right here, right here, right here. I mean, they're so close to 2 that you're not going to be able to tell exactly where they go. Where's your y-intercept this time? Yeah, you do. 2.1. Your y-intercept is when x equals 0, so your y-intercept is 2.1. So also it's going to be kind of like where you can barely tell where to plot it, because 2.1 is so close to 2. Then we have a point at 2, 3, or actually we skipped 1, 2.3. So right 1 up 2.3, and then 2, 3, which we already had that point by knowing the rules, right? And then we have another point at 3, 5. So 1, 2, 3, up 5. And then 4, 11 would be just 1 unit off up there. Okay, so now that we have a sketch of our exponential curve, what's the domain? Correct. That's what it always will be for exponentials. What is the range this time? 2 to infinity, right. And then for the end behavior, as you go to the left side of the curve, the y values are approaching 2, the asymptote. On the right side of the curve, the y values are approaching infinity. Okay, once you write that, go to the next page. What do you mean? Oh yeah, that'll be part of the quiz. You'll have to write the equation of the asymptote. So it'll just be y equals whatever number it crosses through. Okay, now we're going to learn how to do the opposite. They've given us the graph this time. They're asking us to write the equation. Well, when you look at the graph, we see that it's an exponential curve. So we know what the equation should look like. Pay attention. It should look like this, right? Because it's an exponential function. Where is the asymptote of this one? 0. You can see that it starts to flatten out right here at the x-axis, which is y equals 0. Now, when the asymptote's at 0, doesn't that mean that the curve has not been shifted up or down? And that also lets you know that the a value is the same as your y-intercept. Where's the y-intercept for this one? 2, so a equals 2. As long as your asymptote's at 0, your a value is your y-intercept. Now, we don't know b yet, but we know something about it. What do we know about the b value? Just by looking at the picture. It's going to be greater than 1 because it's a growth. Okay, but to find out exactly what the b value is, you have to pick a point. Okay, if I follow this curve up, I mean, we don't want to use the same point as the y-intercept. So the next nice point we get to is right here, correct? And what are the coordinates of that point? 1, 6. Well, isn't that 1 an x value? And the 6 is a y value? So now watch what I'm going to do with those points. Okay, watch the board so you don't miss it. I'm going to rewrite y equals a times b to the x. But in the y place, I'm going to put the 6. In the a place, I'm going to put the 2. In the b place, I don't know it yet. All I know about it is it's greater than 1. And in the x place, I'm going to put 1. Now to solve for b, what would I do? How do I get b by itself? This is times 2, so divide by 2. And so b to the first, which is just b, equals 3. So now look, I have all the information I need to write the answer. Y equals a, which is 2, because that was the y-intercept, times b, which is 3, to the x power. Okay, let me show you how you can now use your calculator to check and make sure your equation is correct. Y equals 2 times 3 to the x power. Okay, it looks like mine, right? But to know for sure, go to the table and compare some points. Do we have a point on this picture at 0, 2? Do we have a point at 1, 6? Do we have a point at 2, 18? If I go right 2, up 18, is that a perfect point? Yes. So that's how you know your equation's good. It matches up with the graphs table. Okay, now let's try number 2. we see that this is a graph of an exponential curve. So to write the equation, it has to be in the form y equals a times b to the x power. Where's the asymptote? 0, which means that there have been no vertical shifts. It hasn't moved up or down, which lets you know what? Right, is 3. So your a value is 3. Your a value is the y-intercept when it has not been shifted up or down, or left or right. Okay, what do we know about our b value? Anything? It's greater than 1 because we're dealing with a growth. But to actually know the exact b value, that's when you pick a point. What point would you like to use this time? I would just use 1/6 again, because think about it. When it ends up a 1 right here, you don't even have to do anything because b to the first is just b. If you end up with a 2 right there, you're going to have to do something to cancel it out. Okay? So it's best to pick a point with 1 as the x value. So now, this is your x value, this is your y value. So when I plug them in the equation, tell me what to write. Right. So now to solve for b, what do I do? Right. And so b equals 6 divided by 3, which is 2. So y equals a, which is 3, times 2 to the x power. Okay, now I'm going to graph it to make sure I have the right equation. Y equals 3 times 2 to the x power. It looks very similar to mine, but to match it up perfectly, you got to look at the table. 0, 3. Did we have that point on here? 1, 6. Do we have that point? 2, 12. Is there a point at 2, 12? Yes. So we have the right equation. Okay, I want you to skip 3, try number 4. Okay, where's the asymptote? 0. So that automatically means your a value is the y-intercept, which is 4. Okay, what do we know about our b value this time? Less than 1, but greater than 0, because it's a decay. But to find the exact b value, you pick a point. And what kind of point did I recommend? But if you pick -1, you're going to run into a problem, because you have to then figure out how to cancel out that -1, which is not easy. You should pick a point with a +1. Can we pick this point right here, +1, 2? So then you plug 2 in for the y place, 4 in for the a place, b we don't know, and 1 in for the x. To solve for b, what do you do? Divide by 4, so b equals, which makes sense that it's 1/2 because it's a decay. Okay, I'll go over later what you would do if you had picked a point with -1, but it's just a little harder to solve. Tomorrow you have a quiz.